Hi students, today let us discuss about sparse matrix. So this sparse matrix is a concept where we need to know in data structures. So all the BTech students need to know about this sparse matrix because this is an important question. You are going to see this question in semester exam. Now let us go with a simple way to understand better. What is this sparse matrix? Sparse matrix is also same like a normal matrix, which is having m into n, that is m rows and n columns. But we call this matrix as a special matrix because in this sparse matrix we have more number or maximum number zero elements. So in this sparse matrix we have maximum number of zero elements and minimum number of non-zero elements. That is the reason we call this sparse matrix as a special matrix. Now, before we get into this sparse matrix, we require to remember with three rules. So what are the three rules to remember? First rule, from the given matrix, either it might be 4 into 5 matrix or 4 into 6 matrix, we have to first ensure in finding out number of rows and number of columns as well as number of non-zero elements. So what is the first rule? Finding out number of rows in the given matrix, and second rule, finding out in first rule itself, finding out number of rows, number of columns and non-zero elements in the given matrix. And the second rule we have to remember is implement a triplet form from the given matrix. So what is the second rule to be implemented? We have to create a triplet form. What is a triplet form? Triplet form is nothing but finding the index of non-zero elements with their row and column. So a triplet form is a very simple form which we are going to define the non-zero elements with their rows and columns. So this is the second rule to remember. And the third rule is, from the given triplet form we are going to implement linked list representation. So three rules to remember. First rule, find out number of rows and columns, finding out number of rows and columns, finding out number of non-zero elements. And the second rule, implement a triplet form. And what is a triplet form? Triplet form is nothing but finding out non-zero elements with their rows and columns, that is nothing but index table we are going to prepare. And thirdly, we are going to implement with linked list representation, because in data structures the sparse matrix should be implemented with the linked list representation. Now let us see, for example, I'm just taking a matrix which is of 4 by 6 matrix that comes with 1 2 3 4 5. So I am taking a matrix which is of how many rows? 1 2 3 4, that is 0 to 3, 4 rows with 0 1 2 3 4 5 6 columns. So my matrix comes with 4 rows, 6 columns. From this given matrix, what is the first rule we have to do? From the sparse, in the sparse matrix means the first rule is finding out number of rows and columns along with their non-zero elements. So number of rows, how many rows are there? 0 1 2 3, that means 4 rows. And how many columns are there? 1 2 3 4 5 6. And how many non-zero elements are there? 1 2 3 4 5 6 7 8 9 10. Total non-zero elements are 10. So rule 1, finding out number of rows and columns and non-zero values, was completed. And what is second rule to be implemented? Triplet form. We have to implement a triplet form from the given matrix. For this, we have to define a row, a column, and a non-zero element position. So total how many rows are there? How many rows are there? 4. And how many columns are there? 6. And how many non-zero elements are there? 10. So for your understanding, I am just defining the topmost label with row, column and non-zero. So now let us see. In the first row with the first column, we have to find out, in the first row with the first column, we have to find out from the from the above row columns, we have to find out the non-zero elements position. So the row position was at 0, and where can we find the non-zero element? At the position of 3. And what is the value of that particular position? 3. And again, can we find one more non-zero element in the 0th row? Yes. So again 0th row, 4th column, and the value is 4. And can we find any more non-zero elements apart from these two? No. So shift to next row. Next row, can we find any more non-zero elements here? Yes. Where? In the column, first column, and the value is 1. And again in the first column, at the first row, 3rd column, and the value is 1. And first row, 5th column, and the value is 1. Now again in the second row, first column, value is 2. Second row, second column, value is 4. And we don't found any more non-zero elements in second row. So shift to third row. Third row, first column, and value is 2. Third row, second column, value is 1. Third row, fourth column, value is 5. So in this how can we find any more non-zero elements? We have almost completed all non-zero elements in every row that comes with a specified column indexed. So this is how we are going to find out the non-zero elements from the defined indexed rows and indexed columns. So this particular indexed table will be called as a triplet form. Hope you all understood how we have to implement the triplet form from the given matrix. After we prepare this triplet form,